All right, let's look at some divergence problems. So remember with divergence, it's P sub x plus QY plus RZ. That's the general formula for a divergence, right? So let's look at some examples. We will do some that have, I'll do two that have no points in them and two that have points. So we'll go over 4 problems right now. So first, let's look at a vector. I'm going to write them just in this form. I'm not going to put the i's, j's, and k's in there. I'm certain you can work back and forth. Why'd they put an x there? I don't know why they put an x there. It's out of order. All right. So here's my vector. Now we're just going to look at each of these: the p, the q, and the y. We only need to take with respect to that. So the p with respect to x is going to be 2xz right here. And then the q with respect to y is going to be 2, I'm going to put it in the right order, 2xy. And lastly, the r with respect to z, this is plus, right? So that part goes to 0, and that's just going to be a 2. And remember, you simply add these up. That's all it is. So the divergence of this vector, I didn't name it, but the divergence of this vector is 2xz plus 2xy plus 2. That's the divergence. Notice there's no point, so we don't plug anything in. Fairly straightforward. Let's do one more like this, another one. Let's look at, we'll do 3xyz squared y squared sine z x e to the 2z. Oops, that's got to be a proper bracket there. All right, same thing, px, qy, px, qy, and rz. So p with respect to x, well, that just means the x is going to go away, so it's really 3yz squared. So nothing weird going on there. And then q with respect to y, the 2y, the 2 comes down, right? 2y sine z. And the z, this one's a little tricky. This is a 2z up here, right? So when you take the derivative of an e to the something, remember we got to bring down that coefficient. So coefficient is 2, so this is going to be 2x e to the 2z. And then you just add those up. I'm not going to bother to add them up because you can do that. Okay, then let's look at, so that's no points. So you were not given a point. So that's just the way to calculate it. So now let's look at some that have points. Oh, you know what? This is... Did I really not give you a separate one? Oh, they had a super silly. I'm going to show it to you. It's ridiculous. It's the trivial example. They had this vector in there. And oh, calculate the divergence at this point. Well, what's the divergence? And again, think about what this means. It means at every location the field is moving this way everywhere. And so is there ever a divergence? Meaning, is there a difference in what's happening to you at this point in the field to that point? And no, so this is divergence 0. If you plug that into the divergence formula, notice these all become 0. So there's no divergence there. Ridiculous, absolutely ridiculous. Let's try another one. That's silly. Let's do x, y, z, and y and z. And then our point is 1, 2, 3. So we got p sub x. Well, p sub x is just going to be y, z. And q sub y, well, that's going to be 1. That's easy. And z, not z sub r. R sub z is 1. And so then, now, our divergence is going to be y, z plus 1 plus 1. But wherever you have these variables, you simply plug the point in. So y is 2, z is 3 plus 1 plus 1. So 6 plus 1 plus 1 is 8. And so then you get an actual number value out of that. Pretty straightforward. I don't think this is that difficult. Just whatever the point is, plug in. Just remember, don't confuse the point with the round brackets with the vector with those square brackets, my friends.